Hello friends, the last topic of the second unit is methods of contouring. What are the methods adopted to draw the contour map and how it was get converted from the ground to the sheet, right? There are two methods available, direct method and indirect method. In that direct method also some divisions are there, in indirect method also divisions are there. We will see one by one. Direct method. In this method this is most accurate, but it is very time consuming and tedious process. It takes a lot of time. For small area it is better, and it gives more accurate results, right? Here the instruments was set up. The fly leveling is the major concept adopted here. The instrument was set up, and from the benchmark the staff reading was taken and the height of instrument was determined, and for the required points or the randomly points we hold in the leveling stuffs at various points and determine the RL of that point. But we need to consider what are the elevation points we required. Say for example we require the elevational point of value 46 meter or 48 meter, 50 meter only, right? From the benchmark, the standard benchmark and height of instrument, and if you required the 50 meter means from the height of instrument, the staff reading, if you subtract, you will get the R of the particular point, that you know. So if based on the height of instrument and what should be detected, if you get the 50 means that the height of instrument minus x must be equal to 50. So that staff reading must be seen wherever it occurs. So it is a tedious process that we have to keep on moving the leveling stuff where we have the same reading. Say if we required 1.48 meter must be the staff reading, means the line of sight must coincide to the 1.48 at that point. Wherever the point we have to move trial and error and we have to hold properly. So it is tedious, but the result is more accurate. If such points were marked or pegged, and if you mark or join those points, that line is the same elevation point. Similarly for 48, similarly for 46, similarly for various numbers of. So this is the procedure adopted. Fly leveling I have explained. The instrument was set up and readings were taken over the benchmark and the height of instruments was determined, and the staff reading required to the fixed point on the various contours is determined by subtracting the RL of each contour from the height of instrument. So for example, if the height of instrument is 82.48 and the staff reading required to get the elevation value for 82, 81, 80 means for 82 the staff reading must be 0.48, for 81 it must be 1.48, and for 80 it must be 2.48. so that if you detect these values from this, you will get the elevation values. So where those points you have to keep on moving. So from here the elevation value is getting down, so obviously it is a slopey down terrain. The point is marked with the help of peg wherever you obtain the same reading, right? Then if you are able to take all the readings, if you are not able to take, you have to move, and the same procedure has to make new height of instrument. The staff readings are then calculated in the similar manner, and the procedure has to be repeated. This can be done by dumpy level, or even we can have theodolite, compass, or plane table traversing can be adapted to determine what is theodolite, which is the starting point of the third unit, right? Next direct method is the radial line method. What is radial line method? From the figure itself I try to explain. You read this paragraph by passing it here, right? Suppose consider a hilly terrain. I placed the instrument in a position such a way that I tried to make exact straight radial lines. In this radial lines I tried to hold the leveling staff and obtain the RL of those points. From the benchmark plus staff reading over the benchmark, you will obtain the height of the instrument at this position. If you detect these staff readings, you will obtain these points RL value. Similarly over all the thing. From the value you can say the terrain is slopy over this, or it is a hilly, or where the ridge lines is coming, where the valley is coming. From the judgment of the value and by the eye judgment you can correlate. So this is also the direct method, and it will also take time and consuming. If it is small area, better. Mostly for the hilly terrain this method is adopted and most suitable for it, right? Similarly, the temporary benchmark first established at the center and near the ends of the radial line. The contour points are then located and marked on these lines, and their positions are determined by measuring these distance. So since we are able to measure the distance with the taper or some other thing, so we can plot in the sheet also, right? So that only we can obtain the contour interval and the horizontal equivalent. We have discussed about these points that can be determined, right? If the terrain is too slopy and we can't hold the tape or chain, in that means one more method is available. We will see at the end of the video. They are then plotted on the plan and the contours drawn by joining all the corresponding points with the help of the plane table instrument in the field itself. Next is the indirect method. In this method, the points located and surveyed are not necessarily on the contour line, but by spot level are taken along the series of the lines, right? And the intermediate points can be obtained by doing the interpolations. This method of contouring is also known as contouring by spot levels. In that indirect method, mainly three methods can be used. First one is the square method or the grid method. Entire whole area can be divided into number of squares, the side of the which may vary from 5 meter to 30 meter depending upon the nature of the ground and the contour interval required. The square need not be of same size, it may be a rectangle or a square, right? So the corners of the squares are pegged out and the reduced levels are of these points are determined with the level. See, the entire area is plated into a square or a grid. Say the point corners A, B, C, D, E, F, G, and here for the vertical line or the y-axis 1, 2, 3, 4, 5, 6, right? So from here itself it is 7, here it is 6. So the notation can be adapted. This is A1, A2, A3, A4. Similarly B1, B2. So on each point the leveling stuff was holded and the RL of each point was determined. So the equal elevations are get joined, right? And it is one more example, and we can freeze the direction of the field also with the help of compass. So from that you can obtain the joint equal contour maps. This shows where the valley line, where the ridge line. If the terrain is too flat, the contour interval can be more, and if it is deep elevation, it will be very close, right? So such a thing can be obtained using the square method or the grid method. Both the name are same. Next, by cross section, here this is predominantly applied for the construction of road, railway or canal, since the center line must be splitted into equally two. If the terrain is so depression, the grids formed and the elevation value obtained, from that you can see 70.6, 69, 68, again it is keep on rising. The center here it is falls like a V shape or channel like, right? So in that you can get the 68.8, 69.1, 69.4. the interpolation value here obtained is 69. You can join those points. Similarly for 70, similarly for 71, and the intermediate you can get 68, 69. It get closed circle also can be obtained, may not be also, right? From that you can determine how the terrain is and how the cross section look like, right? So this method is also called as X section method or cross section method. And the last one is the tachometric method. This is the method when you are not able to use the chain or tape to measure the distance. The tachometric principle itself can be used directly to get the distance also. There we use the tachometric constant, that is the distance can be obtained by the formula D is equal to Ks plus C, where K and C are the constant and S is the staff intercept. The staff intercept is the difference between the top and the bottom readings. Here from the leveling staff we need to get the three readings. So the top minus bottom gives the staff intercept S, and K and C are the constant. The K predominantly you assume as 100 and C will be 0. So 100 into the staff intercept gives the distance directly. This we will discuss in the third unit in detail, right? So the tachometer is a transit unit having the diaphragm fitted with the two stadia wise. The horizontal distance between the instrument and the station may be determined by multiplying the difference of the staff reading of the upper and lower stadia wise with the stadia constant of the instrument, which is usually 100. Thus the tachometer is used for both the vertical as well as the horizontal measurements. This is the most suitable method in hilly areas, as the number of stations which can be commanded by a tachometer is far more than those by a level, and thus the number of instrument settings are considerably reduced. The number of radial lines are laid out at a known angular interval, and representative points are marked by pegs along these radial lines. Their elevation and distance are then calculated and plotted on the plan, and the contour lines are then interpolated. I hope you understood about the various direct method and the indirect method to draw the contour map for the various application, right? Thank you, friends.